The volume of a growing spherical cell is V, which is equal to 4/3 pi r cubed, where the radius r is measured in micrometers. 1 micrometer is equal to 10 to the negative 6 meters. We want to find the average rate of change of the volume with respect to r, radius, when r changes from the following: 5 to 8 micrometers, 5 to 6 micrometers, and then 5 to 5.1 micrometers. Okay. So the first thing we need to look at is the fact that we have the volume as a function of r, which is equal to 4/3 pi r cubed. Okay, so this represents the sphere, right? And so then we want to talk about, okay, the average rate of change. So recall that the average rate of change is going to be the following. It's going to be V of R2 minus V of R1 divided by the radius 2 minus R1. So what we want to do is, for the first one, we want to find what is the average rate of change going from 5 to 8 micrometers. So we want to find V of 8 minus V of 5 divided by 8 minus 5. So that becomes 4/3 pi, or let's rewrite that there. So we have 4/3 times pi times 8 cubed minus 4/3 times pi times 5 cubed over 8 minus 5, which is 3. So we get 2048 over 3 pi minus 500 over 3 pi divided by 3, which gives us 172 pi. Okay, and now we want to go from 5 to 6. So we have V of 6 minus V of 5 over 6 minus 5. So we have 4/3 pi times 6 cubed minus 4/3 pi times 5 cubed over 6 minus 5, which is 1. And so we get 864 over 3 pi minus 500 over 3 pi. And we're dividing that by 1. So we end up getting 121 and 1/3, or 0.3 pi. And then we're going to go from 5 to 5.1. So V of 5.1 minus V of 5 over 5.1 minus 5. So we have 4/3 pi times 5.1 cubed minus 4/3 pi times 5 cubed all over 0.1. So we plug in 5.1 cubed and we get 176.87 pi minus 500 over 3 pi divided by 0.1, which gives us approximately 102.01 pi. Okay, so if you take a look here, when the increments are getting smaller and smaller, we can see that the average rate of change of this volume is decreasing here. 172 pi to 121 1/3 pi, and then 102.01 pi. Okay, now the next thing here that we want to find is we want to be able to find the instantaneous rate of change of V with respect to R when R is equal to 5 micrometers. So we know that the volume in terms of R is equal to 4/3 pi R cubed. We want to find the derivative of that. So finding V prime of R, 3 times 4/3 is going to be 4, and that's going to be 4 pi R squared. Okay, now we want to find the instantaneous rate of change when R is equal to 5 micrometers. So we want to find V prime of 5. We're going to plug it in for R. So 4 pi times 5 squared is then going to give us 100 pi, and that's micrometers cubed per micrometer. Okay, next, we want to be able to show that the rate of change of the volume of a sphere with respect to its radius is equal to its surface area, and then explain geometrically why this result is true by using the same analogy we did in the previous exercise. Okay, so what you want to do is, okay, let's take a look at a sphere. All right, so we know we have a sphere, and then this sphere has a radius of R. Okay, and then what we do is we're then going to expand this sphere by a radius. Okay, and this radius represents the change in R. So that means that we've increased this. So from here to here, this represents R plus the change in R. So this is what it looks like geometrically. Okay, and then what we want to do is we want to find out, okay, what is the volume of the new? So we know the volume of the new is going to equal 4/3 times pi. Well, the radius of the new is going to be R plus the change in R cubed. And we know the volume of the old is 4/3 pi R cubed. So now what we want to do is we want to find the change in the volume, which is equal to the volume of the new minus the volume of the old. So the volume of the new is 4/3 pi times R plus the change in R cubed minus 4/3 pi R cubed. So now we need to expand this. So when we do, we get 4/3 pi times R cubed plus 3R squared times the change in R plus 3R times the change in R squared plus the change in R cubed minus 4/3 pi R cubed. Okay, now if we distribute this and then combine like terms, we end up getting 4/3 pi r cubed plus 4/3. Let's see here. Pi r cubed plus 12/3 pi r squared times a change in r plus 12/3 pi r times the change in r squared plus 4/3 pi times the change in r cubed minus 4/3 pi r squared. So now that we distribute that, we can eliminate those. And let me go back to correct this because this should be 4r negative minus 4/3 pi r cubed. So now we can eliminate those. And so now what we're going to do is now we're going to factor out what they have in common, which is 4/3 pi times the change in r. So what we have left is 3r squared plus 3r times the change in r plus the change in r squared. So therefore that gives us the change in v. Okay, so now what we want to do is now we want to find the change in v over the change in r. So we know the change in v from what we just found is 4/3 pi times the change in r times 3r squared plus 3r times the change in r plus the change of r squared. And we're dividing that by the change of r. And so what that does is that allows us to eliminate those. So now we end up getting 4/3 pi times 3 pi r. So we're going to distribute that to all three of those terms. So we end up getting 12 over 3 pi r squared plus 12 over 3 pi r times a change in r plus 4/3 pi times a change in r squared. So we end up getting 4 pi r squared plus 4 pi r times a change in r plus 4/3 times a change in r squared. Okay, so I want you to take a look here that these are going to be very small because the change in r is small. So therefore, we end up with 4 pi r squared as our change in v over the change in r. And if we go back here, that's what we got for the derivative in part 2 here in part B.